Welcome to Module 5 of the Sustainable Adaptive Teachers Training. This introductory module provides you with fundamental knowledge about virtual reality, VR, technology, and its pedagogical applications. Throughout this training, you will explore basic concepts of digital pedagogy, understand key competence frameworks for technology-enhanced learning, and discover practical ways to integrate VR into your teaching practice. Importantly, this module emphasizes accessible, low-cost approaches that can be implemented without specialized equipment, making VR accessible to all educators regardless of technical expertise or budget constraints. The estimated duration for completing this module is 15 to 20 hours, which includes time for hands-on experimentation, reflection, and practical application. Digital pedagogy is not simply using technology in the classroom, it represents a fundamental shift in how we think about teaching and learning. According to UNICEF's Superstar Teacher Toolbox on Digital Pedagogy, effective digital pedagogy shifts from teacher-centered to learner-centered practices where students actively participate and construct meaning. Technology is not the goal. Enhanced learning is the goal. Technology is the means. For example, in traditional pedagogy, a teacher might lecture about the solar system. In digital pedagogy, students might explore a VR solar system, manipulate planetary orbits, observe effects, collaborate to solve problems, and receive immediate feedback. The teacher's role shifts from information provider to facilitator and guide. The SAMR model, developed by Dr. Ruben Puentedura, helps us understand how technology integration can range from simple enhancement to genuine transformation. When you first start using VR, you might be at the substitution level. Students watch a 360-degree video instead of a regular video. That's okay. It's a starting point. As you grow more comfortable, you move up. At augmentation, you might add interactive elements. At modification, students might work in teams to explore different VR environments and compile findings. At redefinition, the transformative level, students might design and build their own VR experiences to demonstrate mastery of concepts. The key insight: aim for transformation, but recognize that enhancement is a valid starting point. This model helps you intentionally plan how technology enhances your pedagogical goals. Technology enhances teaching and learning in multiple interconnected ways. For accessibility, consider a student with mobility challenges who can virtually visit any location through VR, or a student in a remote area accessing world-class museum collections. For personalized learning, adaptive platforms can present material at the right level for each student. Engagement increases because digital experiences often align with students' natural interaction with technology. Assessment becomes more authentic instead of paper tests. Students can demonstrate learning through projects, presentations, and portfolios. Global collaboration tools let your students work with peers across continents, developing intercultural competence. Resource access is virtually unlimited. Platforms like UNESCO's ICT framework provide extensive free materials. Finally, learning analytics help you understand student progress and adjust instruction accordingly. Effective VR learning experiences require thoughtful pedagogical design. The most common mistake is starting with, "We have VR. What can we do with it?" Instead, start with, "What do students need to learn?" And then ask, "Can VR support this learning?" Structure is crucial. Before the VR experience, prepare students, explain objectives, review controls, set expectations. During the experience, provide guidance without over-directing. After the experience, reflection is essential. This is where learning consolidates. Ask, "What did you notice? What surprised you? How does this connect to what we've been studying?" Even with individual headsets designed for collaboration, students can share discoveries, compare observations, work in teams. Remember, VR is the experience. but learning happens in the reflection and application. Finally, technical planning is practical pedagogy. Know what to do when, not if, something doesn't work. These frameworks provide structure for professional development in digital education. DigCompEdu, developed by the European Commission, is particularly comprehensive. It recognizes that digital competence for educators goes beyond technical skills to include professional engagement, how you use technology professionally, digital resources, finding and creating, teaching and learning, managing digital instruction, assessment, digital tools for evaluation, empowering learners' accessibility and personalization, and facilitating students' own digital competence. You can self-assess using the DigCompEdu self-assessment tool. UNESCO's ICT framework takes a global perspective and emphasizes progression from knowledge acquisition, basic use, through knowledge deepening, applying ICT to real-world problems, to knowledge creation, students producing new knowledge. TPAC emphasizes that knowing technology isn't enough. You need the intersection of technological knowledge, pedagogical knowledge, and content knowledge. For VR specifically, you need to know the technology, understand pedagogy, and master your subject content. This is where frameworks become practical tools. Let's walk through a real example of designing a VR lesson on photosynthesis. First, identify your content. You need students to understand the process of photosynthesis at the cellular level. Second, choose your pedagogy. Immersive experiential learning is ideal for visualizing microscopic processes. Third, select technology. A free app like Mel Chemistry VR lets students experience being inside a plant cell. Fourth, design the sequence. You might start with traditional reading to build vocabulary. Then use VR for immersive exploration, where students see photosynthesis happening, followed by a hands-on lab to connect virtual to physical. Fifth, plan assessment. Perhaps students create labeled diagrams of what they observed, write explanations, or teach peers. Sixth, reflect on the lesson. Did VR enhanced understanding compared to diagrams alone? What would you change? This template can be adapted to any subject and VR resource. Congratulations on completing Module 5. You now understand what VR is, recognize fundamental principles of digital pedagogy, and can identify key competence frameworks for using VR in education. But understanding is just the beginning. Now comes application. Start small. This week, simply explore free resources. Watch a 360-degree video relevant to your subject. Think about where immersion could enhance understanding in your curriculum. This month, use the frameworks and templates we've discussed to design one simple VR lesson. You don't need expensive equipment. Start with what's accessible. Test it. Reflect on it. Refine it. Over the year, continue developing. Join online communities of VR educators. Share your successes and challenges. Learn from others. Remember, this is a journey, not a destination. Digital pedagogy continually evolves, and frameworks like DigCompEdu recognize progression from newcomer to pioneer. Start where you are, use what you have, do what you can. The resources listed here will support your continued development. Most importantly, remember that technology serves pedagogy. Always start with learning objectives. Then select appropriate tools. Thank you for your engagement, and welcome to the future of education. Let's start with the fundamentals. Virtual reality is often misunderstood as requiring expensive equipment, but that's not the case. At its core, VR is about creating immersive digital environments. The level of immersion can vary greatly, from simple 360-degree videos viewed on a smartphone to fully immersive experiences with dedicated headsets. What matters most is not the technology itself, but how we use it pedagogically. For an excellent 60-second introduction, I recommend watching What is Extended Reality XR? This video clearly explains the relationship between VR, AR, and MR within the extended reality spectrum. this is crucial information. VR doesn't have to be expensive. The most accessible option is Google Cardboard, which can be purchased for under €10 or even made from cardboard and lenses. Combined with free apps and your students' smartphones, you can start VR education immediately. For schools with limited budgets, browser-based VR platforms like Mozilla Hubs require no special equipment, just a standard computer and internet connection. Google Arts and Culture VR offers free virtual field trips to museums and cultural sites worldwide. The key is starting with what you have available and gradually exploring more advanced options as comfort and resources allow. These are not futuristic dreams. These applications are being used in classrooms worldwide today. Virtual field trips through Google Expeditions or Google Arts and Culture VR eliminate geographical and financial barriers. A classroom in a small town can visit the Louvre Museum or walk through the Great Reef Barrier. Science teachers use apps like Chemistry VR to let students explore molecular structures from inside. Language teachers use platforms like Mondly VR for conversational practice. The beauty of these applications is that they don't require you to create content. Numerous free resources already exist. Your role as educator is to select appropriate experiences, provide context, and facilitate meaningful learning from these experiences. Not everything needs VR, and that's okay. The goal is to identify where VR adds genuine pedagogical value. Ask yourself these questions about your curriculum. For example, if you're teaching about ecosystems, a VR experience that lets students shrink down to insect size provides a perspective impossible otherwise. If you're teaching history, visiting reconstructed ancient cities in VR offers immersion that textbooks cannot. However, if you're teaching basic arithmetic, traditional methods might be more effective. VR is a tool, not a solution for everything. Use the decision framework. Choose VR when the experience significantly enhances understanding compared to other methods. Remember, UNESCO's guidance that effective technology integration always starts with pedagogical objectives, not with technology itself.